This video will present an overview of the ISO 19650 Part 1 document in relation to the concepts and principles. So just a brief agenda, we'll do a bit of an introduction to the documents, then I'll do a detailed overview of the Part 1 documents looking at the different sections, and then I'll do a summary of them according to ISO 19650 Part 1. So just to define, or in the title of the documents, organisation and digitalisation of information about buildings and civil engineering works, including building information modelling, information management using building information modelling, is the purpose of ISO 19650 Part 1, and that's the context in which we'll look at this presentation. So just a bit of an introduction, why would you use ISO 19650? For efficiency, for designing, constructing, and operating buildings, for arranging and organizing logical structure of design information and construction information, and then for the processes of transition information from design stage, through construction stage and across the operational or maintenance stage of building and civil engineering projects. So the ISO documents, there's part one and part two, and the first document looks at the concepts and principles that are overarching of the processes, and part two looks at the actual delivery phase, the actual processes for the design and construction information as it moves through the managed information stages. And then as part of part two, you have the National Annex per country, and a lot of countries do adopt the National UK Annex, just because the BS standards are as relevant in most countries unless you have your own annex in your particular region or country. So the scope of the ISO 19650 Part 1 document is defined as outlining the concepts and principles for information management at a stage of development or maturity through a project, and then also described as building information modeling being used in this process. And at the end of this, you can offer recommendations for a structure to manage information as well, as a result of following the ISO documents as well. And it is applicable to the entire life cycle of any built asset. Any building, from a house to multiple houses to a hotel, hospital, or civil engineering projects as well, from a bridge to wind farms to anything that can be used as a built asset essentially. And then it can be adapted, the ISO document can be adapted to assets or projects of any scale and complexity. And just to go through some of the terminology in the documents, including responsibility matrix. So this describes the involvement of individuals by roles or functions in completing tasks or deliverables required for that asset to be constructed and operated. And then this can indicate accountability, consultation, and informing alongside any obligations to complete the tasks or deliverables. And this is contained in the responsibility matrix. We also have other terminology such as spaces, and this is defined as a limited 3D extent defined physically or notionally. We also have actors, which is an individual or an organization involved in the construction process. Appointments, which are agreed instructions to provide information on a BIM level 2 project, essentially. Appointed parties, which is the information source provider concerning the project or the built asset, or the providing the goods or the services for that project. Then we have the appointing party, and the appointing party is also known as the client or the owner or the employer. And in this case, we'll refer to the appointing party as the client, assuming that the client is in the top end of driving the project. And then you have the delivery team, which are the lead appointed parties and their appointed parties. So this can be the structural engineer, the civil engineering firm, the architectural firm, or if it's a multidiscipline company, obviously they're all the appointed team. And then they may have subcontractors providing different services. So an architect might appoint a party to do interior design or do some sort of fit out design, for example. And the same goes for, structural engineers. Civil engineering may also appoint other parties, and those parties can be appointed within their own company as well. But you'll always have a lead appointed party, so that's usually the architectural team or structural team or civils team could lead that on a kind of simplified project like that. Then you have the task teams, which are the individuals that are brought together to perform a particular task. So to design a building, or to design the earthworks, or to design the drainage system. These are your task teams, whether it's civil engineering, structural, or architectural. You have things called assets, which are, it can be a piece of furniture, it can be an air handling unit, it can be a floor, it can be a stairs. It's anything that's of value to the organization that will be owning or operating the building. And just some other terminology you'll come across is project information, life cycle, delivery phase, which is obviously the design and the construction stage. You have operational phase, when the building will be in use, trigger events. So these will be different events within a project for when you might need information. So when the planning is granted by the local council, whatever the case may be, then the trigger event for that is that's going to lead on to the tender documents being produced. So to think of those as almost key decision points as well, to pull in information. So some other terms related to managing information, you'll come across an OIR, Organizational Information Requirements, and this just is relation to the company or the employer or the client, and what their goals are with the project, if they want to capture all the information, all the installation information. Um, this will be included in a document called an OIR, and this is at a quite a high level. An OIR just informs of their company goals and their intent of the project, and if that includes BIM, then all the better, and their reasons for using BIM. Then you'll have an AIR, which is related to asset information requirements, so related to a specific piece of equipment or a unit, a piece of furniture, a light fitting or an air handling unit, or a certain element that needs to be maybe maintained within a project, windows or doors, etc. And these are related to the operation of an asset. So when do all the windows need to get replaced? When do the filters need to get changed in the air handling units, for example? And then project information requirements, or PIR, and this is in relation to the construction and the design stage of the asset. What information is needed for the contractor on site to actually install that air handling unit or to lay that particular tile finish? What information do they need? Do they need the manufacturer information, specification information, and even where to source the materials as well? And then exchange information requirements, or an EIR, is the information requirements in relation to a particular appointment. So what is the exchange information? What is the type of format that files will be shared from an architect to an engineer, or from the engineer or the architect to the client or the employer? What is the information requirements? What format of DWG do you need to use? What version of Revit do you need to be using? That type of information in your exchange information requirements. Other terms: information exchange, information model, asset information model, and you'll come across these in the ISO documents as well. So project information model, this is an information model relating to the delivery phase of the project, so the design and the construction phase. And then the PIM can also be used to express the intent of the design, or even a 3D representation of the building or the asset to be constructed. Federations, this is the creation of a combined information model from various information sources. As it says in the thing, this is pulling together various information from different appointed parties or different consultants on the project, and federating their information. So even bringing together the architectural model and the structural engineering Revit model, for example, is known as federation. And the various information used during federation can come from different task teams, so engineering team, architectural team, or civils team as well. What's an information container? So this is a structured information container, and this can be a file or a document, or it can be a subdirectory information file, including a 3D model, document, a type of table or a schedule or agenda, or some subset of an information file, or even a chapter in a building regulation or a section in a building regulation as well. Other terms related to information management, you have status codes, and this is metadata that it is attached to your file or your document, describing the suitability of the content of that particular piece of information. Is it being used for work in progress? Is it being archived, or is it being published, or is it just for coordination, for example? And then obviously BIM is the use of a shared digital representation of a building or a civil engineering project to enable that design, construction, and the operational process to form something you can depend on as a basis for making decisions throughout that process. A common data environment, or it's also something like BIM 360 or a cloud storage solution, is an agreed source of information for any given project or asset for collecting and managing information. And then some other terms: level of information needed, capability, capacity, and level of information need is just a structure which defines the magnitude and detail of information that you require for a certain object, or a certain piece of furniture or a certain floor finish. And the capability is related to the task team or the delivery teams or the architect's office. Do they have the capability? Do they have the Revit skills? Do they have the software and the hardware capable to deliver a BIM level 2 project? If not, do they need to upgrade systems? Do they need to train up their staff? And then capacity is, do they have the enough resources to perform those particular functions? Do they have an in-house BIM manager or BIM coordinator with those qualifications or skills relevant to perform that role as well? And then section two kind of looks at building an asset and project information and different perspectives when working collaboratively as well. And some of the main principles include asset information models and project information models as the structured sources of information that are needed to make choices during the whole life cycle of a building or a civil engineering asset. And the AIM and PIM can include structured and unstructured information, and then the transfer of the relevant information from, say, an asset information model and a project information model at the start and end of a project as well need to be considered. And asset and project information is also valuable to policymakers, regulators, even company investors or property developers or insurers and other external parties as well. And these should be applied in a way that is proportional and appropriate to the scale and complexity of the project. You don't want to be overproducing information, but at the same time, on a more complex project, you don't want to be underproducing information. You want to ensure everybody has the correct amount of information at the relevant stage. So defining the information needed and the output information model, some of the main principles, creating an asset register, and the client should specify their reasons for requiring certain information that they request for the air handling unit. Why do they want the installation date? And that can be related to maintenance. They know when to replace it in 10, 15 or 20 years. They know when to replace the filters, and the same could go even go for a light bulb or other installed equipment that may need required maintenance. Other things to be considered are support for compliance and regulatory responsibilities, risk management, support for business questions. When do all the windows need to be replaced? What is the cost of investing in a more higher quality window now if we only have to replace them in 15 or 20 years as opposed to 10? The management and capacity and utilization of assets, management, security and surveillance, any support for future renovation that you may have information or a building information modeling that will help you renovate in the future by having that existing data, and then predicted and actual impacts as well of replacing a lot of windows. What's the sort of impact that's going to have on occupants of the building? Obviously the building's going to be shut down for a time, but by having this information to hand you can kind of predict how that might happen further in the future. And then for operations, maintenance and repairs, replacement of objects, if it's windows, air handling units, floor finishes, showers, piping, any sort of mechanical equipment that may need to be replaced as well. And then decommissioning and disposal. You have all of that information at hand as well, and it helps you manage them. And the information delivery loop within a project, some of the principles. So information is needed for making key decisions throughout a project. Information is specified progressively. Therefore, at the early design stage, you're not going to give the full specification for a wall finish or a floor finish, and you're only going to progress that information, maybe when it gets to the detailed design stage or up to your construction drawing production as well. And then information requirements should be passed to the most relevant party. So making sure that you're not sharing information with parties that don't need access to it, for example, and you always make sure that you have your point of contact in the relevant parties as well. And then information exchanges involves the sharing and coordination of information through something called a common data environment, a cloud solution, or something like BIM 360. And then what about setting the information requirements and planning for the delivery of the information during the design and the construction stage of a project? So some of the general principles: information requirements specifying what you want, plan the information delivery, how and when is this going to happen, then deliver that information. So deliver the drawings, provide the Revit model, produce specification documents, and then check and approve it as well. So it goes to a QA and a QC process, and is there a way to automate that QA QC process either through your common data environment or through some sort of approval workflows, and then ensure that there's a feedback loop as well, in that if something gets rejected, that there's a process that it can get sent back to the creator of that particular piece of information for it to be rectified and then sent through the approval process once again. Then looking at the delivery team's capability and capacity, some of the principles are that the client should review the capability and capacity of the potential delivery teams of the architect's office, of the engineering firm, of the civil engineering firm, and any of the teams or the contractors or the subcontractors prior to engaging them or awarding them the contract. And then that review can be completed in a number of steps. For example, where pre-qualification is being utilised, but it should be completed before the contracts are awarded. Therefore, you know their capability before you actually award them the contract. Then looking at the information delivery planning, some of the principles, how information will meet the requirements defined in the AIR or in the EIR, when information is going to be delivered, so dates attached to that, and initially with respect to the project stages or the particular assets, and then management milestones, and later with respect to the actual delivery dates of that particular piece of information. How the information is going to be delivered. Is it going to be a PDF drawing? Is it going to be shared through your common data environment? Is it going to be a Revit file of Revit 2020, or is it going to be a DWG file or a DSXF file? So defining all of this are very important as part of that process. And then how the information is going to be coordinated or federated with information from the other appointed parties, such as the other design consultants or the interior designer or the civil engineer on the project as well. And then managing the collaborative production of information. So a common environment and workflow should be implemented, and this allows information to be accessed by the people that need to or are required to undertake their particular role or function. So the structural engineer is going to need access to the architect's model within the common data environment, and the architect is going to need access to the structural Revit model as well within their common data environment. And then issues in the information model should be avoided during the production of information. Therefore, if it's avoided in-house internally before it gets into the common data environment, therefore it's not making its way to site. But if you capture it in the common data environment, that's fine, but obviously try to capture it with your own QA and QC internal workflows in the architect's office before a model gets released, by doing certain checks on the model and having a BIM coordinator or a BIM manager to perform those checks, or even if it's just a manual check, or if it's if Revit performs a model checker as well, using different functions within the software. And then, for example, fire protection materials being incompatible with the required fire rating of a wall, checking this stuff in-house allows that fault or that error not to make it to site, and then you're not going to have a compliance issue and have to remove or rebuild a wall for whatever reason. Then looking at the common data environment, the kind of solution and the workflow. So a common data environment should be used for managing the information and any of the building or civil engineering and project delivery information as well during the design and the construction phase. And the common data environment should support the information management process as well. And then at the end of the project, the information is required for the asset management and should be moved from the PIM to the AIM, the project information model, to the asset information model. Some of the principles within a common data environment, you're going to have three states known as a work in progress, shared, and a published, and these can be separate folders, or it can also be metadata as well. I prefer a folder structure. It works quite well with BIM 360, and then each information or file or document managed through that common data environment should have metadata, and as specified in the ISO document, that should be a revision code or in accordance with an agreed standard. If your national annex in a different country, for example, not in the UK or even in Ireland, has a different agreed standard before the project goes ahead, and this will be specified in your BIM execution plan. And then applying something called a status status code, and then showing the permitted use of that information. Is it for construction? Is it for information only? Is it only for planning purposes? Or what's the purpose of that? And there is a status code in the back of the ISO Part 2 document status code list that you can adhere to. And then looking at the work in progress state, this is used for information while it is being developed by its delivery or task team, and it should not be visible or accessible to any other task team. So in the common data environment, having your own work in progress area for your design office or your particular role in the project. And it's important if the common data environment is implemented through a shared system, so that everybody can control access, and that the information is almost just one source of truth, that it's getting moved from work in progress area to a published or to a shared area to enable better management of that information, and reduce any sort of duplication of information. The check, review, approve, transition of files kind of looks at it compares the information file against the agreed processes in your BIM execution plan and in your information delivery plans. And then the transitions should be made by the owner or the task team or the author of that particular piece of information. So if it's the architect releasing the architectural drawings, it should be that particular task team that perform that function. Then the shared state, this covers being able to enable constructive and collaborative development of the particular piece of information. So being able to get feedback from the structural engineer or the civil engineer on the architectural design. And this should be visible and accessible, but should not be editable by other teams within the project as well. And that can be done in something like BIM 360 by controlling permission levels. And if editing is required, an information container or document or file should be returned back into your WIP or your work in progress state for updating it or rectifying something that requires an edit to it. Then the review and authorize workflow. If an information file or document meets the information requirement, its state is then changed to published. And then if it's not meeting the information requirements, it should be sent back to the work in progress state, and then it should be updated and then resubmitted, and then go through the approval process again. So it's all about quality assuring your information. Then the published state, this looks at using the information that has been approved for use. For example, in the construction of a new project or in the operation of a building or a civil engineering asset. And then the PIM at the end of a project or the AIM during asset operation contains only information in the published form or in the archived state as well. And then the archive state, and this is used to hold a record of all the information documents that have been shared and published, and as an audit trail as well of their progressed creation and production on a project. And then just looking at a summary of BIM according to ISO 19650, it looks at the management of data is different from information production and delivery. An information management process is started each time a new delivery phase or operational phase appointment is also made as well. So each time a new team come on board, an information management process is started again for that particular appointment. And then a common data environment workflow is used to support the collaborative creation and production and management as well, and sharing of and any exchanging of information between different parties or different stakeholders within a particular project.